Okay, so for this last video, we're just going to jump through the remainder of these three examples here. If I'm going too fast, just remember that you can slow me down with the playback speed, or you can just watch the video multiple times if you don't get it the first time. So we're focusing on this second example here. We have x over 8 plus 1 over 6 equals 7 over 24. And we want to get rid of this constant here that's crowding this variable term. So let's get rid of that. We're just going to subtract 1/6, but we do it to both sides. And rewriting our left and right hand sides now, we have x over 8 equals 7 over 24 minus 1/6. Now, before we isolate this variable even further, it would be a huge advantage if we could simplify this right-hand side first, so let's do that. We find a common denominator, a denominator that's common to both of these numbers. So what number is common, or sorry, what is the lowest multiple lowest common multiple of 24 and 6? The lowest common multiple of 24 and 6 is just 24, because 6 can just multiply directly into 24. How do we do that? Well, we multiply 6 by 4, and that will get us a denominator of 24. So, rewriting both sides, x over 8 equals 7 over 24 minus, what's this fraction now? 1 times 4, the numerator is now going to be 4. 6 times 4, the denominator now is going to be 24. We now have a denominator that is common. This is the denominator of 24 for both of these fractions, so we can simply subtract these two numerators. So, making some room here, we have x over 8 equals 7 minus 4 over 24, which is 3 over 24. And if we have a fraction, that can possibly be simplified, then we should simplify it. So let's simplify this fraction on the right-hand side. We know that we have a factor of 3 on top here, and there is actually a factor of 3 over here as well, right? There's a factor of 3 in 24, and we could, if we wanted, we could write this more clearly. What is 24? What is 24? 24 is really just 8 times 3, right? 24, and 8 times 3 are ultimately the same number, right? It's just that here it's written as one number, and here that same number is written as a product of factors. And the reason I've written this as a product of factors is we can see that the factor in the numerator of this fraction cancels with the factor in the denominator. And we can see that this is now simplified. We have 1/8 on the right-hand side here. If you didn't do that simplification, it wouldn't be the worst thing in the world, but it does help to simplify our calculations, especially in this last step here. So in this last step, we can now finally isolate our variable. We have our variable term being divided by 8, so let's multiply it by 8. There we go. Do the same thing to the right-hand side. What's left? What is left here? Well, x equals 1. X is just left on the left-hand side, 1 is just left on the right-hand side, so that is our solution there. We write it in a box. More quickly, let's jump through these last examples. Here we have x over 6 plus x over 8. This particular example, in this particular example, we don't have actually a constant term on the same side as the variable term. We actually have two variable terms. And so what we need to do here is we need to find a denominator for these two variable terms that is common so that we can simplify the numerators. So that's our goal, to simplify the numerators. I'll show you, by the way, before I do the correct version of this, I'll show you one common incorrect way to approach a problem like this. And I'll label this as wrong. Don't do this. It is a common mistake, so avoid doing this. Here we can see an x on top and an x on top, and we might want to add them together to get 2x over maybe something like 14, just adding the denominators together. This is wrong. Don't do this. It is really tempting to want to add these two variable numerators together, but we can't yet because those two terms don't have the same bottom number. So let's give them the same bottom number. What is the lowest common multiple of 6 and 8? The smallest number that both of these numbers can multiply into? 24. So we can say that LCD, the lowest common denominator, is going to be 24. So how do you turn a 6 into a 24? You multiply it by 4. And you have to multiply the numerator by the same factor in order to not change the value of the fraction. How do you turn an 8 into 24? Well, you multiply it by 3. And you do the same thing to the numerator so that you don't change the value of the fraction. So that is our first simplification. You can see that we have worked on this left-hand side of this equation, and you might be tempted to also multiply the right-hand side by 3 and by 4, but you actually don't have to here because in this particular case, we haven't actually multiplied the whole left-hand side by anything. We have actually just multiplied the numerator and the denominator of this fraction by the same number, and so really, those two factors would cancel. You could see that you could argue very effectively, and this is in fact true, you could argue that really we haven't multiplied by anything at all on the left-hand side. We've really just multiplied by 1. 4 divided by 4 is just 1. 3 divided by 3 is really just 1. So when we're changing how these fractions look in this particular way, we're actually not changing their values, and so we don't need to balance this equation in any particular way. So no balance needed for these particular changes we're making to the look of these fractions. Okay, so 4 times x is 4x. I hope that wasn't confusing. And 4 times 6 on the denominator here is 24. 3 times x is 3x. 8 times 3 in the denominator here is 24. And on our right-hand side, we just have 7. These are two fractions on the left-hand side with the same denominator. We can write that as such. So just writing it as one denominator, and we have 4x plus 3x. What is 4x plus 3x? Well, we can simplify this numerator now because those are two like terms, right? They are both x terms. It's not, one of them isn't sneakily x squared or anything. We can gather these like terms together, so that's just going to be 7x. And now what we can do is we can simplify the right-hand side. We can simplify the left-hand side. And when I say simplify, what I should say is we can isolate. We can isolate this variable. So here, let's isolate this variable, isolate x. We can isolate this variable x in one of two ways. We have 7x in our numerator, and I'll write that in red just to stay consistent. So we have 7x in our numerator here. We could divide both sides by 7 and then multiply both sides by 24, or we can multiply both sides by 24 and then divide both sides by 7. It's really up to you. I will first get rid of the denominator, though. That will be my choice. I will first get rid of the denominator. It is mathematically simpler to get rid of the numerator first, but I don't want that. There's potential for confusion there, and I want to get rid of that potential for confusion. So, and let me write my product without an x because I don't want you to confuse my multiplication symbol. I don't want you to confuse my multiplication symbol with my x variable. So I'm going to multiply both sides by 24. Just to get rid of the denominator on the left-hand side. And simplifying, on my right-hand side, I have 7 times 24. What is 7 times 20? It's 140. And then 7 times 4 is 28. So this should be 168 on the right-hand side. And now I have 7x on my left-hand side. I want to get rid of that 7. So what I'm going to do is I'm going to divide both sides by 7. So if I divide the left-hand side by 7, I'll do that in a different color just to show you that that's the operation that I'm introducing. So divide by 7 gets rid of that 7. Do the same thing to the right-hand side, just to show that I'm balancing the equation. And here, I just write my simplified left-hand side and my simplified right-hand side. What is 168 divided by 7? That is 24. And there is our solution. And I will save the decimal for the next video.